Welcome to Day 5 of the KMC Technologies Group Microsoft Copilot Studio implementation course. Until now, our agent has been able to understand users, retrieve enterprise knowledge, collect information, and guide a structured conversation. Today, the agent crosses an important boundary. It begins performing real enterprise actions. We'll learn how Copilot Studio tools, connectors, and agent flows work together, and then we'll build our first transactional capability, creating and retrieving IT support tickets safely. Today we'll learn when the orchestrator invokes tools, how agent flows work with Power Platform connectors, and why input and output schemas matter. We'll also cover connection ownership, retries, duplicate prevention, and safe error handling. Then we'll build the create ticket flow, map our Day 4 topic variables into it, create a ticket record in a back-end system, and return a ticket ID and status to the user. A production agent should not write directly into enterprise systems without a controlled boundary. The conversation topic first produces validated user data. That data is passed through a tool contract. The tool invokes an agent flow where business logic and validation are applied. A connector then performs the actual system operation against a ticket store, such as Dataverse, SharePoint, or an IT service management platform. The result travels back through the same layers. This architecture gives us clear control over what the agent can do. Copilot Studio provides several ways to extend an agent beyond conversation. Agent flows are low-code workflows that can be created in Copilot Studio or Power Automate and exposed as tools. Power Platform connectors provide managed access to supported SaaS and enterprise platforms. Custom connectors and APIs are useful when a proprietary system does not have an appropriate pre-built connector. Some architectures can also delegate tasks to specialized agents, and emerging integration patterns, including MCP-based capabilities, may provide additional options, but the production principle remains the same. Authorization and business rules belong in the back end, not solely in the conversational layer. Before building the flow, define the contract. Our Create Ticket tool accepts 6 important inputs. Issue category identifies the approved ticket category. Affected asset identifies the device, application, or service involved. Urgency accepts values such as low, medium, high, or critical. Summary contains the required issue description. Attempted fixes is optional and should never include passwords or secrets. Requester UPN should come from authenticated user context when available. The tool then returns ticket ID, ticket status, success, and a safe user message. Now let's create the agent flow. Create the flow inside the KMC solution so it can participate in proper application lifecycle management later. Define trigger parameters for category, asset, urgency, summary, attempted fixes, and requester identity. Next, validate the inputs before doing anything with the back end. Reject missing required values and unsupported or unsafe inputs. Then create the ticket using Dataverse, SharePoint, or a test ETSM connector. After the record is written successfully, build the outputs. Return success, ticket ID, ticket status, and a user-safe result message. Finally, save and publish the flow and make sure the required connection references are resolved. The back-end schema should be simple and strongly typed. For a first implementation, your ticket store might include ticket ID, requester UPN, issue category, affected asset, urgency, summary, attempted fixes, status, created on, and source channel. Status could use controlled values such as new, in progress, resolved, and closed. The category and urgency values should align closely with the choices defined in the conversational topic. And never store passwords, MFA codes, access tokens, or other secrets in a support ticket simply because the user typed them into the conversation. Return to the Create Support Ticket topic we created in Day 4. Find the placeholder action after the user confirmation step. Replace it with the published Create Ticket tool. Now explicitly map each topic variable into the corresponding tool input. Map issue category to topic. Issue category, affected asset to topic. affected asset, and continue through urgency, summary, and attempted fixes. For requester identity, use authenticated user context where supported. Then capture the outputs into variables. Never assume that the system succeeded simply because the tool was called. The post-tool conversation needs an explicit success or failure branch. If tool success is true and ticket ID contains a value, then, and only then, tell the user that the ticket was created. Display the backend generated ticket number and initial status. Otherwise, use the safe user message returned by the flow. You can offer the user one retry or route the request to human support. Most importantly, never let the language model infer or guess that the transaction succeeded. Connection design becomes especially important once an agent performs real transactions. Production tools should not depend on the personal account of one developer or maker. Use an approved organizational connection strategy. Store connector relationships as connection references inside the solution. Apply least privilege permissions. Document connection ownership and credential renewal. And keep development, test, and production connections separate. Avoid granting broad administrative privileges simply to make a connector work. A crucial security concept is that prompt instructions and topic conditions are not security controls. The backend must validate the data again. Validate category and urgency inside the flow or API. Authorize whether the requester is permitted to perform the operation. Enforce record-level permissions in the destination system. Reject malformed or excessively long inputs. Normalize or sanitize data where necessary. Log diagnostic information safely. And return only user-safe error details to the agent. Transactional agents also have to plan for duplicates. Users retry, networks retry, flows retry. Without controls, the same conversation could generate multiple support tickets. One technique is to generate a unique client request ID and store it with the ticket. Another is to check whether a recent matching request already exists. If the backend API supports an idempotency key, use it. Be cautious with automatic retries around operations that are not naturally idempotent. And if a timeout occurs, don't automatically assume that the transaction either failed or succeeded. Now let's build a second tool to demonstrate a read operation. Create a GetTicket status flow. Its inputs should include the ticket ID and the authenticated requester identity. First, validate the ticket number format. Then query the destination system. Before returning anything, verify that the requester is authorized to view that particular ticket. Return only safe fields such as the ticket ID, current status, safe summary, last update, and next action. If the ticket does not exist, or the user isn't permitted to view it, return an appropriately safe message. Let's watch the complete transaction. The user describes an Outlook problem. The structured topic collects the remaining ticket details. The values are validated and displayed back to the user for confirmation. After confirmation, those values are passed into the Create Ticket tool. The agent flow performs backend validation and invokes the configured connector. The destination system creates the ticket and generates ticket ID KMC 10284. The flow returns success equals true along with the ticket ID and initial status. Only at that point does the agent tell the user that the support ticket has been created. A production-ready tool must be tested beyond the happy path. Create a valid ticket and verify the exact ID and status. Submit a ticket with a missing required summary and confirm that validation prevents the write. Test a critical security incident and ensure the generic ticket tool is bypassed in favor of escalation. Simulate a connector outage and confirm that the agent does not claim success. Test a duplicate retry and attempt to retrieve a ticket belonging to another user to verify that unauthorized data is never returned. When a tool behaves incorrectly, inspect the tool contract and flow run history first. If the tool is never offered or invoked, improve its name, description, and orchestration instructions. If input values arrive blank, verify variable mappings and scope. If the flow fails authorization, Inspect connection references, permissions, and environment policies. If it works for the maker but not for users, check whether the connector is using maker credentials or invoker credentials. If the agent reports success without a ticket, strengthen the explicit success and ticket ID checks. And if duplicate records appear, review retry behavior and idempotency. Day 5 introduces some of the most important patterns for enterprise agent engineering. Every action should have an explicit contract. Permissions should follow least privilege. Validation must occur in the back end. Failures should produce useful but safe messages. Success should never be assumed. Duplicate writes should be intentionally prevented. And every connection and system boundary should be designed so that administrators can understand, support, and govern it. Before completing Day 5, verify the implementation. The create ticket flow should exist with strongly defined inputs. Back-end validation should be working. A real ticket record should be created successfully. Outputs should include both success and ticket ID. Topic mappings must be verified. The failure path should be tested. Connection references should be documented. Duplicate prevention should be considered. And the get ticket status capability should be implemented and tested. Your homework is to document how each connector authenticates and identify the least privilege permissions it requires. Also gather your organization's DLP requirements and Microsoft Entra requirements. These become essential in Day 6. Now that our agent can perform real transactions, we need to secure those actions using authentication, identity, data loss prevention policies, least privilege, and governance controls. This completes Day 5 of the KMC Technologies Group Microsoft Copilot Studio implementation course. Our agent has now moved beyond conversation and can perform real enterprise transactions using governed tools, agent flows, connectors, explicit inputs and outputs, validation, and safe error handling. In Day 6, we'll secure these capabilities with authentication, Microsoft Entra ID, DLP, least privilege, and governance. Thank you for learning with KMC Technologies Group. Keep meeting commitments.